welcome to Solve with Dani. And if circles have ever confused you, then today, hopefully, they're about to make sense. So this is geometry we're talking about, and we're going to talk about Thales Theorem, named after Thales of Miletus. Hopefully I say that right. And we're using it to master like central angles in circles as well as inscribed angles in circles and finding missing arcs, angle measures, and stuff like that. And there will be a part 2 to this video where we solve things algebraically. But in this video, we're just going to stick with numbers. Okay. So look for part 2 coming soon. All right. So by the end of this video, hopefully you'll know exactly what the angle measures are going to be, what the arc measures are going to be. Life will be good. So Thales theorem says, and take a, look at the diagram as I'm explaining this to you, okay? If a triangle is inscribed in a circle, and one side of that triangle is the diameter, so all the way across, going through the center point, then the triangle is automatically a right triangle. No work required. Yay, no work required. Who can get excited about that? But here's why, okay? Don't just memorize it and take my word as Lord, right? So the diameter will create a semicircle as you see. Let me get a marker out here. As you see here, we have a semicircle, okay? So here's the key rule. An inscribed angle measures half the arc it intercepts. In a diameter or in that semicircle, that's 180 degrees because a full circle, 360. So half a circle, 180, okay? And if we're looking for an inscribed angle, so it's touching the edge of the circle, that means it's going to be half of 180, which is 90. So that's why the angle opposite the diameter will always be 90 degrees. So Thales theorem states that this is a special case where an inscribed angle, no matter where it is on there, as long as one of its legs is going through the diameter, it will be 90 degrees. So quick refresh. A central angle is going to be equal to its intercepted arc. And an inscribed angle is going to be half the value of its intercepted arc. Okay, so let's do a bunch of examples to help you out practicing that. Okay, and I recommend if you want to draw these on a separate sheet of paper, like pause the video, draw it so you can be doing this with me as well. Okay, so here in the first problem, we have triangle ABC is reflected across that diameter BD. So when you have circles with a center point, you see there's a little dot in there. It will always show that, okay? And it's also giving us that the measure of angle ADB is 40 degrees. 40 degrees. And we want to find all these other angles, okay? Well, using Thales theorem, we know that because this is a diameter, this inscribed angle will be half its intercepted arc. Half of a circle is 180. So this is 90 degrees, and so is angle C. So angles A and angle C are 90 degrees right off the bat. Well, how many degrees are in a triangle? 180. So if you've got a 90-degree angle and you've got a 40-degree angle, we'll just take that away from 90. So then we have a 50-degree left. And because it was reflected, that means size was preserved during that transformation. Okay, so I've labeled them all in. So now let's put it with the answer key. Okay, so angle BDC right there, that's also 40 degrees. Angle BAD, that's one of our 90-degree guys. Angle BCD, also 90 degrees. Angle ABD, 50 degrees. I know, my Apple Pencil not in yet, so my handwriting's a little messy. It's okay. Angle CBD, 50 degrees. Angle ABC, ooh, angle ABC, that's this whole angle right there. That's going to be 50 degrees plus 50 degrees. That's going to be 100 degrees. That was fun. And then angle ADC, so that whole big angle, so that 40 plus 40, That's going to give us 80 degrees. Very good. Okay, let's do a few more examples. All right. So, given this fun picture, and we're looking for some central angles, some inscribed angles, we're looking for a bunch of stuff. Okay, and it looks like my little arc marks did not transfer through. So there we go. Those are supposed to be arcs. All good. Okay, a central angle. An example of a central angle would be anything that comes to, at that point, E. So angle AED is a central angle. Angle AEB is a central angle. Angle BEC is a central angle. And angle DEC is also a central angle. I'm not going to list them all out, like write them all out, but you have 4 central angles. The E needs to be in the middle. An inscribed angle means it's an angle where it's touching the circumference, the outer part of the circle. So, for example, that would be DBC is one, and also ACB as well is an inscribed angle. So this one only has 2 inscribed angles. A chord is where it goes from edge to edge. Doesn't necessarily have to go through the center, but it could, and that would be called a diameter. But for this, I'm going to say chord BC. Chord BC there. Okay, a minor arc. A minor arc means that it is less than half the circle. Less than half the circle. And you show it with a little wee, a fun little arc there, like little rainbow. Okay, and arc BC right there, that right there is a minor arc. Also a minor arc, AB is a minor arc. DC is a minor arc. And AD is also a minor arc. So as long as it's less than half, life is good. Let me erase these. Oh my goodness. Erase. Okay. Oh, keeps clicking off my eraser. All right. And then a major arc means that it is more than half the circle. When you have a major arc, you want to label that with 3 letters. So you know where you're starting, where you're stopping. Okay, so for example, I can do major arc DAC. That's this whole shebang. As long as I label it with 3, life is good. I don't need to put a 4th one in there because it's giving me direction. Okay, I'm starting at D, going through A, ending at C. Okay, that's an example of a major arc. It is more than half of the circle. Label it with 3 letters. Okay. Neat. Let's get down into some fun stuff. Okay, so we have an inscribed angle of 32 degrees. We want to look for its intercepted arc, which is right here. That minor arc AB, an inscribed angle, is half the measure of its intercepted arc. So this is going to be 64 degrees. And for me, I really like to label it on the diagram. I like to color code it because it's going to be a little easier to see, especially as you start getting to more complicated problems where some arcs might overlap. So the other colors is a little nicer to have. Okay. So it says given circle E. So I know that E is my center point of this circle, which means DB is a diameter. So that means arc DAB is a semicircle. So just for your notes, arc DAB is 180 degrees. So just for fun, if I wanted to find arc DA, I would subtract them. So 180 minus 64, that's going to give us, let me get pink. If I had a highlighter, I would use a highlighter too. 116 degrees for arc DA. All right. Or AD, I guess. And it did ask me for that. Convenient. All right. Who are we looking for next? We are looking for arcs CD and arcs BC. So now we're looking for the rest of the circle. So we know an inscribed angle is equal to half the intercepted arc. And what we also know is that a central angle is equal to its arc. So if arc AB is 64, then angle AEB must also be 64 degrees. And if arc AEB is 64, if angle AEB is 64 degrees, then that also means that angle DEC must be 64 degrees because they are vertical angles. Remember that from a previous unit? Yeah, it's coming back. So we have vertical angles there, which means arc DC, or arc CD as we asked for it, is also 64 degrees because you've got that central angle equal to its arc. Oh, this is so exciting. And then that last arc, there's so many different ways we could solve this. We know a full circle is 360, so we could add up the pieces we have and subtract it from 360. I could also see that I have some linear pairs happening here. So 64 degrees, its linear pair is angle AED. So since it's on a straight line, 180 degrees is a straight line. I could also say that's equal to the central angle is equal to its arc. So the rest of this must be 116 degrees. Ah, that was fun. Very good. All right, I got a couple more. And if you want, I would encourage you, pause the video here, try it on your own, and then hit play to see how you did. Okay. All right, so we have angle ADB is 80 degrees as a given. We also have angle ADC is 110 degrees, so no linear pair. All right, what are we looking for? So arc AB. Well, since this is given circle D, let me move this out of the way a little bit. We know that this D is a central angle, so that means arc AB, central angles are equal to its intercepted arc. That must also be 80 degrees. And then what else are we looking for? Angle CDB. Well, all those angles at a point sum to 360 degrees. So what we can do is add up 110 and 80. I don't know why I typed that in my calculator. I didn't need it, but it doesn't hurt to type it in. It's all good. No shade. That's 190 degrees. And then we are going to subtract that from 360 degrees to get 170 degrees. So that obtuse angle is 170. So now we can figure out the rest of the arcs, which is so nice. So we have 170 degrees here. You know, your girl loved to color code. All right, now it's looking for, let's get another color going. Arc CAB. So it's looking for this whole piece, this major arc. So we're going to take 110 and add it to 80 degrees. How did I get 110? This arc AC must also be 110 because central angles are equal to its arc. So sorry for skipping a step there. And the sum of those two is 190 degrees. And then lastly, it wants arc CA. Oh, we found that. Silly us. 110 degrees. Yay! I hope you did good if you paused it. All right. Couple more, getting a little beefier now. All right. So again, I encourage you, pause the video, see how you do. So in these next two examples, we're just going to look for the indicated missing side. So on this one, we are looking for arc PD. And I know it's a little tough to tell by this picture, but 35 degrees is this angle right here. Okay. So inscribed angle is equal to half of its intercepted arc right away. I know that sucker is 70 degrees. 35 times 2 is 70. And here we have FD is our diameter. So we've got a semicircle there. So to find arc PD, I'm going to do 180 minus 70. And we will get 110 degrees for our final answer. So not too shabby, not too shabby. All right, this is the last one. So if you really want to be like, all right, Dani, I'm going to go for it. This is your chance, okay? This is your chance. So find the indicated missing side. It's given us a lot of information here, which is nice. We got 2 angles. We've got a pretty large arc, but we do not have a diameter. So we've got a quadrilateral here. We can't assume anything's parallel. It might be. We cannot assume if it's not given to us, right? So what shall we do? Give up and cry? No. Okay. Sorry, that was so dramatic. Okay. Let me get some highlighters going here. All right. This angle is 65 degrees, and its intercepted arc is arc VFG. So arc VFG cannot wait till my Apple Pencil comes in. Oh my goodness. Is 65 times 2, which is 130 degrees. All right. And then we also have another inscribed angle. I'll use another color. Let's do pink. 119 degrees is right there. This is a very chubby highlighter. There we go. And its intercepted arc overlaps with that one. Whee, it's all the way around. Big major arc. Big major arc. All right, so that's major arc. Whee. It starts at V, goes through F, and it ends at H. Big kahuna. That big kahuna, that big pink arc is 119 times 2, which is 238 degrees. All right, we've got some overlappingness here, right? So it gave us that arc GH was 168 degrees. And it's overlapping with that 238. So to find that missing FG arc, I'm going to subtract the 2. So we're going to take 238 and subtract 168 from it. And that's going to give us 70 degrees for that cute little arc right there, arc FG. And since from V, so arc VFG was 130, now we know 70 of it. Now we're just going to subtract 130 and 70. Oops, dropping my calculator. To get 60 degrees for our missing arc. So fun. So hopefully like using different colors to kind of like really draw out that arc so you can see those overlapping pieces. I personally find it helpful. If you're like, Dani, it's too many colors, like you do you, boo. Do what works. This works for me. I'm a very visual, colorful person. All right. So I hope you hate math a little less today. And there's going to be a part 2 where we do some of these problems, but algebraically getting a little more involved with some variables and stuff. So have a great day.